Hello students, welcome to the next lecture of 11th Standard Chemistry, chapter number 13, Nuclear Chemistry and Radioactivity. Now in this lecture, we are going to study the topic of nuclear fission and nuclear fusion. Yesterday, in previous lecture, we had seen that the nuclear reactions can be carried out artificially also. That is, induced or artificial radioactivity can be carried out. In that only we are going to study the topic nuclear fission and nuclear fusion. So let's start with the first topic, that is nuclear fission. Now fission means what? Fission means to break. Okay, fission means to break. So nuclear fission involves splitting of a heavy nucleus into two fragments, accompanied by release of large amount of energy. So nuclear fission, the word itself tells you that you are dividing the nucleus, you are breaking the nucleus. Okay, so nuclear fission involves breaking the heavy nucleus into two fragments or two daughter nuclei, where and plus what you get, a large amount of energy is released in such nuclear fission. Okay. Now here we will explain with the help of an example. Uranium-92 having mass number 235. When it is bombarded with neutron. Okay. When uranium nucleus is bombarded with neutron particle, it breaks up into two daughter nuclei, that is barium-56 having atomic number 56 and mass number 142, and krypton with atomic number 96 and mass number 91. Now in this process, along with these two daughter nuclei, 3 neutrons are also released. Okay, and plus a large amount of energy is released. So with this example, we have seen that uranium, when bombarded with neutron particle, what do you get? It breaks up into barium and krypton, along with 3 neutrons is released. Okay, 3 neutrons are released and a large amount of energy is also released. So what you can say about this radioactivity, what you can say about this nuclear fission? That each fission may lead to different products. Okay, so each fission may lead to different products. It is not necessary that uranium on fission will always give only barium and krypton. This is not so. It may give different products at different fission. Okay, so it is not giving the same products at each fission. It may give different products during each fission. Okay, so this sentence means that each fission may lead to different products. Now we have seen that the mass is lost. Whenever something you are breaking, you are losing some mass, and that mass loss is converted into energy. So nuclear fission process is accompanied by large amount of energy. Very high amount of energy is being released because you are losing some mass in this. Now we have again seen that in this example, one uranium nucleus, when it is undergoing fission, okay, what it is giving out? 3 neutron particles it is giving out. Now let's see what does this 3 neutrons give. Now see, here we are using neutron for bombardment. Okay, so what happens? We are starting with one neutron, we are taking it from outside, but when the reaction when fission is proceeded, okay, when you bombard this uranium nucleus with one neutron, in product what you are getting? Okay, you are getting 3 neutrons. So these 3 neutrons, what these 3 neutrons will do? This will again undergo, or they will again react or bombard with another uranium nucleus, producing 3 neutrons each. So here we are getting, suppose this is one uranium nucleus we have taken, we have bombarded with 1 neutron, we have got 3 neutrons here. Now let's see what each neutron will do. So this neutron will again bombard, or it will break this uranium nucleus, in giving you 3 neutrons each. Okay, the second neutron particle, from here I am telling you. Okay, so second neutron will again break another uranium nucleus and will give again more 3 neutrons. And the last also which you have got over here, okay, that will again break another nucleus of uranium, and again you will get 3 neutrons. So here each neutron, this neutron, how many neutrons you have given? 3. And these 3 neutrons are further giving rise to how many neutrons? 9 neutrons. Okay, so you can say this is a type of chain reaction. Okay, it is not stopping. Now you are not providing any neutrons from outside. Here, in the first when you have started the fission, you have provided neutron from outside. But in further process, do you require neutrons from outside? No, because the neutrons are being produced in the fission itself. So these neutrons are further, we don't need to provide them from outer. Okay, externally we don't have to provide them. They are internally, त्यांचे fission झाल्यावर ते produce होतात. So what happens? Neutrons is being produced, and this continues in a chain reaction, chain manner. Okay, this continues in a chain. It is sort of chain म्हणजे एका chain प्रमाणे ते reaction होत जाते. So this reaction is also called as chain reaction, and it is very difficult to stop this reaction. And this reaction may further continues to it will result in an explosion, and this type of reaction is used in your atomic bomb. Okay, in atomic bomb this nuclear fission reaction is taking place. It is due to the chain reaction which is being produced. Okay, so chain reaction, the neutrons are being produced in a chain. Now this uranium nucleus, we have seen that this fission may lead to different products. So each time uranium may not give you barium and krypton. Sometimes it gives you, or many times it gives you different products. So there are 400 ways in which your uranium nucleus can undergo fission, and similarly it has been observed that it gives rise to around 800 types of products. Some of them are new products in the some of them are the new element in your periodic table. So in this way, using by uranium, we can also get new element in our periodic table. So this what we have concluded, that each fission नेहमी uranium बरोबर न्यूट्रॉनचं bombardment जेव्हा होतो तेव्हा सेम तुम्हाला बेरियम किंवा क्रिप्टॉन भेटतं का? नाही. Not always you get barium and krypton. Each fission gives you some different products, but neutrons भेटतात. Yes, 3 neutrons, one fission will give you 3 neutrons, आणि ते 3 neutron परत तुम्हाला किती neutrons येतात? 9 neutrons. In this way it is going on a cycle like a chain, and hence it is also called as chain reaction. Now one fission, how much energy is released? Around 200 million electron volt energy is being released per fission. Okay, for one fission around 200 million electron volt energy is being released. So this much energy is very high. So you can imagine how much energy is released during nuclear fission. Now we will study next point. Moving on to the next topic, that is nuclear fusion. Now fusion is to add up. Okay, fusion is to add up. So in this type of reactions, what happens? Two nucleus add up to give a bigger nucleus. Okay, two nucleus of smaller masses add up to give a nuclei of bigger mass. Now we know that our Earth receives energy from sun in the form of radiation, and we know that sun is continuously emitting energy. Now what is the reason behind that sun is continuously emitting energy? So there is nuclear fusion going on in the sun. Okay, so that's why we get energy in the form of radiation. The Earth receives energy in the form of radiation from the sun due to the nuclear fusion. So let's see what are the reactions taking place on the sun which leads to your nuclear fusion. There are two hydrogen atoms combined to give you one hydrogen atom with mass 2 and releasing one electron. One hydrogen with mass number 1 and mass number 2 will give you, combined to give you helium of mass number 3 and atomic number 2. Okay, two helium nuclei again combined to give you helium nuclei of mass number 4 along with one hydrogen nuclei of mass number 1. And last is helium nuclei of mass number 3 and hydrogen of mass number 1 further combined to give you helium of mass number 4. So this is the main reaction. What it is that hydrogen is there, hydrogen combined to give you hydrogen with mass number 2. This further combines to give you helium, and then this two helium combines to give you the helium of mass number 4. So this energy or the light which you will receive from sun is made basically due to the formation of your helium is being formed. Hydrogen nuclei is being fused together to form to give you helium nuclei, and in this reaction a large amount of energy is being released. A large amount of energy is released. Okay, a large amount of energy is released. You can very well say that how much heat do we receive from the sun, that itself only we can say that how much energy is being released in such type of fusion. आपल्याला माहिती आहे की आपल्याला आपल्या पृथ्वीवर सूर्यापासून जी किरणं येतात तर सूर्यावर कुठले रिॲक्शन्स होतात, न्यूक्लिअर फ्युजनमुळे ती जी हीट जनरेट होते, जी लाईट जनरेट होते, जी आपल्या पृथ्वीपर्यंत पोहोचते, ती कशामुळे होते, युअर न्यूक्लिअर फ्युजनमुळे होते. अँड व्हॉट हॅपन्स इन न्यूक्लिअर फ्युजन, युअर हायड्रोजन कंबाइन्स टू गिव्ह यू helium. Okay, now we can compare if nuclear fusion is also giving you large amount of energy, nuclear fusion is also giving you large amount of energy, which is the best one. So nuclear fusion is the best one to give you the large amount of energy. Okay, it produces relatively more energy per mass. So the positive point is what? That fusion gives relatively more energy per mass. If you take same mass of the fuel on both the side, and one you are reacting in the fusion way and one in the fission way. Okay, एक मध्ये न्यूक्लियर फ्युजन करतोय आणि एक मध्ये न्यूक्लियर फ्युजन करतोय, तर तुम्हाला एका 1 ग्राम मास पासून कुठे जास्त एनर्जी भेटणार आहे? You are going to get for nuclear fusion, you are going to get relatively more energy per mass. So this is favorable. But the only drawback of this is that it requires very high temperature. Okay, very high temperature is required for nuclear fusion. That's why we know that we say, scientists are saying that sun is very hot, very hot. Why it is hot? Because already their temperature is very high, and so since temperature is very high, this type of reactions, nuclear fusion is being going on. Temperature खूप high असलं तर तुमचं nuclear fusion reaction ही होते, आणि त्याच्यामुळे we know that sun वर एवढं टेम्परेचर आहे आणि तिथे हे पॉसिबल होते, ही रिॲक्शन होणे पॉसिबल होते, and that's why we get more amount of energy. So we can say nuclear fusion is favorable because it gives more energy per mass. 1 किलोग्राम जर आपण घेतलं एखादा फ्यूल, तर कंपॅरिझन केलं की न्यूक्लिअर फ्युजनमुळे आपल्याला जास्त एनर्जी भेटते का न्यूक्लिअर फिजनमुळे, तर यू विल सी दॅट न्यूक्लिअर फ्युजनमुळे तुम्हाला जास्त एनर्जी भेटेल. पण द ओनली ड्रॉबॅक इज दॅट nuclear fusion requires very high temperature, that is 10 raised to the power 8 Kelvin. It is very high temperature, so that's why nuclear fusion is this is the drawback of the nuclear fusion. Okay, this disadvantage you can see. Now we will do one problem. Okay, this is the problem. How many alpha and beta particles are emitted in the following reaction? What is the reaction? Neptunium 93 with atomic number 93 and mass number 237 is being converted to bismuth nuclei of mass number 209 and atomic number 83. So how many alpha and beta particles are emitted? We have to see here. Now we know that if one alpha particle is emitted, mass number decreases by 4. Okay, alpha particle. What is alpha particle? This is alpha particle. So if this is being given out from your nuclei, your product nucleus, daughter nucleus mass कितनी कमी असणार आहे? Mass number 4 भी. So now we will find out the difference. So here 237 minus 209. Okay. So now this mass is only this loss of mass. Okay. This is your parent nucleus. This is parent and this is daughter. So if you look at the change in mass, how much mass has been changed? 28. So when the mass is changed only when your alpha particle is being emitted. So 28 divided by 4, you will get 7. So how beta particle, what happens when beta particle is emitted? Your beta particle is emitted, atomic number increases by 1. Okay, and for alpha particle what happens? Atomic number decreases by 2. When your beta particle is emitted, atomic number increases by 1, and when your alpha particle is emitted, atomic number decreases by 2. Now here, what is the difference? 93. Atomic number changes by, change in atomic number is 10. Okay, change in atomic number is 10. So, but if we know there are 7 alpha particles, we have seen that 7 alpha particles is being emitted. 7 alpha particles are emitted. If we say 7 alpha particles are emitted, so how much? 7 to the 14. So your atomic number should decrease by 14. Atomic number should decrease by 14. But it is decreasing by 10 only. Okay. So it is decreasing by 10 only. So plus 4 is being added. Okay. So there should be plus 4. Plus 4 ni kami ahi. Okay. Mass difference, atomic number difference is 10. Okay. But what we are expecting if we say 7, there are 7 alpha particles. 7 alpha particles आहे म्हणजे त्याचा atomic number कितीनी decrease झाला पाहिजे होतं? 14 नी. It should have been decreased by 14, but it has been decreased by only 10. So 4 add झाले. 4 add झाले म्हणजे 4 increase झाले mass number. Its atomic number is increased by that means its atomic number is increased by 4. That is its atomic number is increased by 4. That means there are 4 beta particles emitted. Okay, so alpha particles emitted are 7. And beta particles emitted are 4. Okay, understood here? If there were only alpha particles, the atomic number would have decreased by 14. But we have seen atomic number is decreased by 10 only. So that means some plus 4 is being added. So when we know when atomic number increases only at beta emission, so therefore 4 beta particles are emitted and 7 alpha particles are emitted. In the conversion of neptunium to bismuth, 7 alpha particles are emitted and 4 beta particles are emitted. I hope you have understood in this lecture nuclear fusion and nuclear fusion also. We will stop here. Thank you.